I'm Ugar. Good morning, everyone. Thank you for joining this morning. Just get the chat function going. There we go. The last session we touched on some questions and digesters. Went through the digester section pretty quickly, only because for level 1 and 2 exams, there's certain things I think you need to focus on for those exams. Definitely a lot to learn about digesters, but not so much in an exam prep for level 1 and 2. If there's any questions that have come out of that, please let me know. This morning we're going to dive right in. We're going to start with reviewing 2 or 3 calculations that you're bound to see on your exams, and then we're going to move into quite a few sample type questions, and if there's time at the end, there's a couple other PowerPoints I'd like to go through. All right, so bear with me. I'm going to share my screen. Okay. Just takes a second for this to fire up. Okay, so like I said, this morning we're going to just talk about a couple of the basic calculations that you're bound to see on your level 1 and 2 exams. Excuse me. There are several calculations that you might run across. I'm going to touch this morning on 3 or 4 that are almost guaranteed to be on the exam. The examples that I'm going to provide are just examples. There may be something very similar on the exam or different units that they may use, but the calculations will remain the same, okay? Let's start with some flow velocity. You might see a question that's similar to estimate the velocity of a grit channel if a stick travels 24 feet in 60 seconds. And again, this question might be similar, or it might say 2 miles in an hour, or whatever the case may be, but the velocity calculation remains the same. So velocity is equals distance divided by time. So in this question, distance traveled is in feet and time is in seconds. So 24 feet divided by 60 seconds, which that stick travels 0.4 feet per second. One thing I'd like to mention on this type of question, back up to the question, it doesn't ask you to provide the answer in a different format than what information is provided to you. It asks simply, what's the velocity of this stick traveling through the channel? So you have to use the information that you have. You don't have to convert it to hours or how long it travels in a day or anything like that. Simply go with the information that's provided to you. And then this question, it simply asks, what's the velocity of the stick traveling in the grit channel? So remember that. Now so we go through the calculation, and using the information provided, you're at 0.4 feet per second. If it wanted to know, if the question, how long does it travel in a day, then you'd have to convert that seconds into hours or into days. So we multiply the seconds by minutes, by hours, and 24 hours in a day. Okay. Another one that you might see on your exam for sure is maybe grit removed, or could be anything removed. It could be solids removed, rags removed, but the calculation is still the same. So in this one, a grit channel removes 175 pounds of grit from a flow of 12 mgd. How many pounds of grit are removed per million gallons per day? So the difference between this question and the last question, it's very specific. It wants to know how many pounds and in that million gallons per day. So the only information that you know in this question are volume of the grit. So you have 175 pounds, and the volume of the flow is 12 million gallons per day. So you find the calculation, grit removed, is volume of grit in pounds divided by the flow. And in this case, it's million gallons per day. So it's simply, you plunk in the numbers from that question, 175 pounds divided by 12, give you 14.5 pounds of grit removed per million gallons per day. Questions on that one? Like I said, these calculations or these questions are similar to what you might see, and they can be used. You could, like I said, it doesn't have to be a grit channel. It doesn't have to be a grid. It could be any other combination of things, but the calculation remains the same. When you're writing the exam, this sample question could have another couple lines of information in there, and you have to be able to pick out what information is valuable to you as to what the question is being asked. So they could put in something similar to, and it's a plant located in Kelowna and has 5 primaries and on and on and on. But none of that information has anything to do with the question you're trying to ask. Okay, so be careful of that too. Detention time is definitely one you're going to see on your exams. In this example, we use clarifiers. Again, it can be used, it could be a clarifier, a bioreactor, primary clarifier, digester. The calculation remains the same. So in this one, a circular clarifier has a flow of 4 mgd and a suspended solids of 3,800 milligrams per liter. The clarifier is 7 feet deep and has a 54-foot diameter. Find the detention time. So first thing you do is grab your, unless you know this calculation off the top of your head, you grab your calculation sheet that will be provided in the exam and find out where the calculation is. And on your calculation sheet, it'll be very similar to this. It'll say, okay, just find the detention time. It's tank volume multiplied by 24 hours a day, divided by the flow in million gallons per day. Oops, sorry. So one of my slides disappeared, but if you you can do your calculations. We will go in one of the other sessions. We're going to go through volumes and how to make sure everybody understands how to find volumes of rectangular, circular, tankage, that type of thing. Another one that will definitely be on your exam are removal efficiencies. And again, we're going to talk about BOD in this equation, but it could be removal efficiency of a primary clarifier, solids in, solids out, bioreactor, mixed liquor, suspended solids. It doesn't matter what the units are or what they're answering, the calculation remains the same. But in this example, is removal efficiency of a tank. You have an influent BOD of 275 milligrams per liter, an effluent of 15 milligrams per liter, and what's the removal efficiency? Removal efficiencies, it's the same calculation for any of the tankage and, like I said, any of the units that they might be looking for. And the calculation is in minus out divided by in times 100. So in this it doesn't show my notes on here, so I apologize for that. But in this calculation, if you have your calculators handy, so it's in minus out, so it's 275 minus 15 divided by in, which is 275, multiplied by 100 will give you your removal efficiency in a percent. There will be probably 1 or 2 questions centered on calculations on BOD and how to figure a BOD for from a lab result. And BOD results are basically you take your initial BOD, in this case it's 5 milligrams per liter, and then your result after 5 days, it's 3.7 milligrams per liter. And it wants to know what the BOD is. So in the calculation for that is, it's initial BOD minus final BOD times the volume of the bottle, which is, the sample bottles are typically 300 milliliters, and divided by the volume of the sample. In this case, if we use like a 3 milliliter sample, you just plunk in those numbers. So it's 5 minus 3.7 divided by 3 milligrams per liter is the volume of the sample, and multiply that by 300, which is the volume of the bottle. So BOD removal efficiencies will 100% guaranteed that those two will be on your exams. So make sure that you understand or have a good handle on those calculations. Make sure that when you go through the exam that you disseminate all the information, pick out what's important for the question, and don't focus on any of the other outliers or information that might lead you down the wrong path. Detention time will be there as well. And removal and velocity I would think will be there as well. So this morning, I just wanted to touch on those calculations. We can put together some more examples, and maybe I'll do that of using those basic calculations, because like I said, I'm sure those ones will be on the exam for sure. So for the next session, I'll have some more sample questions. Okay. I was going to also indicate that you should make sure that you have a converting calculator when you attend the exam. The exams might be in Imperial, or they should probably be in Imperial from the information I understand. But if there's some metric questions on there, or at least some conversions that you have to do, be much easier for you if you have a converting calculator. So any questions on those basic ones? Like I said, we'll do some examples on the next ones. I'll put together a few questions on each to give you some examples that we can walk through. Before we move on to some questions, sample questions.
Hi, morning, Mike. I have a question.
Good morning. Sure.
You see with the BOD one that you did, suppose they don't mention the volume of the bottle. Do we assume it
300?
100?
300, yeah.
Right, yeah, 300. All right, thanks.
Yeah, no problem. In that presentation, I had some other notes in there, but in that, the way we presented with my face on it, they didn't pop up. So that's why I thought maybe we'd do a few more examples later on. But yeah, the sample bottles are that you see in the lab, the small bottles with the small neck on them, those are all 300s. Okay. Good question. Okay, I'm going to move on to some sample questions. Okay, so hopefully everybody can see that the questions popping up on your screen. Just bringing up chat box, so keep an eye on that. Excellent. All right, so let's start going through these. The main factor influencing primary treatment is, everybody can type in an answer or chime in with your microphone, whichever one is more comfortable, easy for you. I know it's early, but somebody's got to take a guess. Flow B, 100% correct. Yeah. This is a really good example of a question. A lot of those, or almost all of those things, affect primary treatment for sure. But when the question says, what's the main factor, and that it would be flow. So good answer. Bulking in a primary clarifier is caused by okay, so a couple answers to C. That is a correct answer, but in this question, the answer would be D. So let's take a little look at that. And you're absolutely right. If you don't remove the sludge, you're going to get sludge bulking. But if the collector mechanism is off, then the sludge won't be removed either. And sludge decomposing is what bulking is. So I totally understand why you tend to want to choose C. But think about these questions, read all the answers, and each one of those does have an opportunity to cause some bulking clarifier. So the answer in that one is D. In mechanical aerator systems, problems such as surging and impeller fouling may result in yeah, that's correct. Non-uniform mixing. I'm going to explain some of these as we go through. So just in case there's any questions on these, it's basically saying you have an aerator system, the impeller's plugged up or fouled, and what's going to happen? Well, you're not going to get the air transfer that you'd want, so you'd have non-uniform mixing in that tank. The next one, stiff white foam is typically an indication of an answer, a B. And another B, that's correct. High FM, high food to microorganism ratio, for sure. There will definitely be something about stiff white foam on your exams, and those are whenever you're looking at a bioreactor or a mixed liquor tank, and when you have a white foam, it means your microorganisms are lower, so you've got more food and less microorganisms.
Question before we move on.
Sure.
What is impeller fouling?
So impeller fouling would be anything if it's there's a rags or something that got on that impeller to plug it up or lower its effectiveness or efficiency to be able to do its job. So if you think of it as a pump, so if a pump was fouled, maybe rags or sticks or something got in that pump and fouled it up, and that's what they mean by impeller fouling.
All right, thank you.
Oh, you're welcome. That was a good question. So this one, to correct Nicardia foam problem in a conventional system, what would you do? So I don't think we touched specifically on Nicardia foam. There's a lot of things that we may or may not specifically have hit on. Should be in your material to read, but there's also some experience component to this as well. But Nicardia foam, basically, when you have foam all over your clarifier, there's only or sorry, in your system. The only one way to get rid of that is you have to waste it off. So the correct answer is B here. I saw an answer of D, place another clarifier outline if available. Definitely a way to, you know, it's always a good option for things if you're trying to correct problems. But in this case, if you have a buildup on a tank, the only way to get rid of it is to increase the wasting. You need to get rid of those microorganisms that are causing that issue. Okay. Bacteria make up approximately blank of the activated sludge. Any thoughts on that one? And the A and a B, a little bit of a trickier question for sure, but the answer is D, 95%. So just think of, you know, if you took an activated sludge sample and you're looking at it under the microscope, and you might have a little bit of sand and grit, you might have some other things going on, but the bulk of that sample under that microscope is going to be made up from bacteria. Okay, so you obviously you'd have to discount any of the water. You wouldn't be considering water there. So maybe think of that question in that context. If you're looking at it under a microscope, what's the bulk of what you're going to see? Dark or black foam is typically a result of everybody jumped on that one right away. Insufficient aeration, you bet. We did talk about filaments and filamentous bacteria a little bit. So chlorine is an effective remedy against all filamentous organisms. Everybody's jumping on true. And now, in almost all cases that you're going to run across in your experience running treatment facilities, you're 100% correct. If I'm running a treatment facility and I have filamentous problems, I'm going to put some chlorine to it, and that's going to fix that problem. This is a good example of a question that might pop up on your exam. And what throws this off a bit is the word all. Because there are some organisms that are not going to be as effectively treated with chlorine. So I totally understand where you're coming from. And if I were you and running a facility, I'd be treating with chlorine just like yourself. But be careful of questions like this that show up on the exam. Remedy against all filamentous organisms. That word and the way that question's framed, you'd really want to take a pause and think about that before you hit an answer. Okay. Filaments are good if they form a strong backbone and add a rigid network to the flock. A couple B's. And get an A. Yeah, so we're a little bit split there. The correct answer in there is A. So just like anything in your treatment facility, any of the bacteria or microorganisms, a balance of everything is what's needed. And some filaments, you know, if you remember when we were talking about some of the bacteria, they actually they build off the filaments. You know, they need those filaments there. They're not free swimmers, or they're not ciliates that are running around finding their own food. So they'd be like a stock ciliate where they need some kind of filaments or backbone to grow on. So just think about that when you're going through those questions. And remember, when everything in a balance in your system is what's needed. So you don't want too many affiliates or filament. You don't want too much of another bacteria or something, but everything kind of works together. So in this question, like I said, the answer is true. Let me back up just a second before we carry on. Remember, I think I've said it all the way along too. Don't focus on a question like this, that, oh, I got this question wrong. It's like, okay, I got it wrong. So what was I thinking about? Why didn't I get that question? Why didn't I have the right answer? And focus on that. It's about understanding to succeed, not focusing on failure or questions that we got wrong. So definitely as we move through, and I appreciate the questions so far. If there's any more, if you're not understanding something, definitely chime in and we'll talk about it. So this one, ashing may occur when? I was waiting for that question. So ashing would be if you'd see fine particles floating off in a secondary clarifier. If you were looking at it and say your effluent being clear, it might be a little bit cloudy. Ashing wouldn't be like rising sludge from denitrification in a secondary clarifier. It would be look like a little bit of a haze in that clarifier. So denitrification beginning to occur. So you would start to see those fine particles, a little bit of hazing, some particles breaking off before it got to the point where you're having denitrification problems. FM ratio extreme low beyond in a normal aeration tank would cause that as well, and potentially excess grease could cause you some ashing issues as well. So the correct answer in there is is D, all of the above. But think about the ashing; it's just the fine particles, a little bit of haze that you might see. And it's a precursor to what's coming, and what's coming is more than likely you're headed down the road of some denitrification. You're going to see some rising sludge, so you need to do something about that. Yeah, make sure you commit that one to memory. I would definitely say there would be a list on the level 2 exam. There's probably going to be an ashing question for sure. The presence of filaments in small numbers does what? So we've got 1D. Any other thoughts? And a B. And a C. Oh, we're all very split this morning. It's good though. Some of these questions really allow us to focus on some points and have discussions. So the correct answer in here is C. So it aids in settling. If you're looking at this question, let's break it down a little bit. So we've talked about that filaments are good in certain quantities because they allow bacteria to build around them. They focus on them, and if that happens, you're developing larger flock which will then settle easier. So that's how you get to the answer in this question. When you look at it, the presence of filaments in small numbers, that's the key too. So it's not indicating that there's a problem. We do want some filaments in our system. So, you know, it's not, you'd be looking for more of a positive answer than a negative one. I'm just going to go this one here. Few or no protozoa may indicate. This is a tough question. I'll give you that much. Now, as you're scratching your head thinking about this question, let's look at it a little bit. So few or no protozoa may indicate there's not much information there. So you don't have a lot to go from. Do we want some protozoa? Yes. No, if you don't have too many, is that, you know, is the FM high or low or normal? You don't really know. That's so in this type of question, it doesn't give you much information. So it's hard to say. You don't want to make assumptions. You can only base your answer on the information that's provided. So in this question, the answer is D, and you basically get there by going, there isn't enough information in that question to point you in a direction of FM high, low, or normal. A little tricky, but you might see something like that too. Odor in lagoons is always due to you got a B, that's exactly right. You got an A there too. So this is a good question to take a little bit of a look at as well. So it's basically odor in lagoons is always, and always is the key word there, due to what? If you have high organics in your inlet, that's probably eventually going to lead you down to some sludge bulking. But either way, the low oxygen level is what is going to cause your problem. Right? High organics inlet doesn't necessarily mean you're going to have a problem. If you have organics coming in, but you have enough oxygen to deal with them, then it won't be an issue. If you have the correct amount of oxygen, you shouldn't see any sludge bulking. And D, ducks and geese is just, you can just throw that out. So the correct answer is B there. A microscopic examination of a lagoon effluent can identify short-circuiting and sludge accumulation problems. Now that's correct, true. If you read through this question really quickly on an exam and didn't think about it, you may think about, oh, the microscopic exam isn't going to talk to me about short circuiting. But if you read the whole question, short circuiting and sludge accumulation problems, then yes, you'll see what's starting to happen in the system, which could be short circuiting and sludge problems. So take a sec, slow down, read those questions. So really good answers, everyone. I'm glad everybody got that. Algae are a normal and needed biological component in a lagoon. Yeah, you bet everybody jumped on that one too. Good answers. Lagoon effluent problems have a number of causes, such as Yeah, that's right. All of those, good answers, everybody. All of those could have a problem there. Historical data is useful in problem solving. Yeah, for sure. You bet it is for sure. Here's another ashing question that you might see. Ashing may be a symptom of over-oxidized or over-aerated mixed liquor. Now, as you're thinking about this one, it's another little twist on ashing. If we talked about ashing being, you're going to see a haze in the clarifier, or some start of fine particles, which is going to indicate some other kind of problem that's either happening at the right now, or that's a looming problem. So if you think about this question, and if you over aerate something and you mix the living daylights out of it, you're going to take all those flock particles, you're going to disperse them. So you've taken a flock particle that's a certain size, and now it's dispersed by 100 times, so it's quite a bit smaller, and it could look very similar to an ashing problem that's caused by something else. So this answer is true. Just really understand what ashing is, and like I said, hazing look, small particles, and what could potentially cause that. And if you over aerated or if you over mixed, it could have something to do with that too. This next question, you're bound to see similar questions like this on your exam for sure. So we're going to go through it, but long questions, a lot of information. Just really take time to read the question, understand what they're asking, look at the data that's provided, and use the information that you need from the data to answer that question. So given the data below, what is most likely the cause of an activated sludge diffusion aeration problem? So if you're looking at your data, see what's the diffusion aeration problem. All this other data, it doesn't really matter whether it's an activated sludge. It could be any other term they want to throw out there, but it's in the diffused aeration problem. So if your blower rate, you're putting out high output on your blower. Your organic load's normal. Your hydraulic load is normal. You got borderline DO. So if you go back up to the first data, your blower is running at a high output. So your blower is running at 100% and you're hardly getting any air out. And then the next one is low turbulence throughout the tank, which goes hand in hand with your low DO because you're not getting the transfer that you need. Yeah, pipes leaking for sure. Really good answer. Was there any questions on that type of question and how to get to the answer? Why can't it be D? So D says under aeration due to low blower speed. But in your data that was provided, the blower is running at high output. Output is high. So the blower is running at the high speed already. So that's why D is not considered in the answers.
Yeah, I kind of knew that answer because the first day as an operator, that actually occurred.
Oh, did it? Yeah.
Yeah.
So the plugged line occurred, or
no, the pipe was leaking.
Yeah. Did it was it leaking in the tank or outside of the tank? And the reason I ask is if it was in the tank, you probably saw a great deal of air.
No, it was outside. You could actually hear it. It was coming through the valve to turn on and off the air. It was actually coming through there.
Oh wow. Wow. So these things actually do happen. hopefully not too often. So just back to that comment, but it's being under aerated. And that's exactly what this question's asking: is the system leaking, or is there a plug or something happening there? And in this, there isn't any other answers except for the pipe leaking to reason that the air is not getting to the tank where it needs to be. Okay. So given the data below, what is the most likely cause of the extended aeration facility problem? So blower's running normally, normal flow going into the system. Dissolved oxygen levels are normal. The airline control valves half open. There's a dead spot on the surface or around like one of the drop pipes, and the dead spot remains when the valve is fully open. Okay, so I have 1B. One A. And I have one A or B. That's a good one. So let's take a little closer look at this one, and just about how to figure out the answer. So the correct answer here is D, is the drop pipe is clogged. You're right in thinking that if there was a header problem, you would have the dead spots on the surface, but you'd have dead spots all over the tank, or your whole tank would be one big dead spot. Additionally, it doesn't say anything about how the blower is running, except that it's running normal. So if your header was plugged, that blower would be trying to run at 100% and relieving its air somewhere else because the whole line was plugged. But if the blower is running normally, you can assume that the header's fine, all of the other drop pipes are fine, and you're getting the air diffusion you need. But it says there's a dead spot around one drop pipe on that aeration tank. So if you put those all together, then you come up with only that there's probably a plug or something wrong with that one drop pipe, not the whole system. Any other questions on that one? Some of these questions on your exam, and there will be one similar to this, you just have to break them down one by one, okay? Or go through that data and really understand, and not, because I understand where you're coming from, but if you think about it, like you said, if the header or discharge pipe was plugged, the whole tank would be affected, not just one area. All right, so if the pump bearings on a horizontal centrifugal pumps are over lubricated, the most important effect is that the extra lubricant would cause what? Yeah, C, that's exactly right. It would cause some overheating. All right. In order to reduce sludge rising, you can reduce detention time by increasing the sludge collector speed or by decreasing the number of clarifiers in use. Is that true or false? So I've got 1 false, 2 that are false. Okay, so the correct answer in this question is actually true. Let me think about how to explain this. So what the question is saying, I'm going to read the question again, then we'll just go through it. In order to reduce sludge rising, you can reduce detention time by increasing the sludge collector speed or by decreasing the number of clarifiers in use. So it's asking you, although it has sludge rising and what the end result of what you're trying to effectively deal with, the question is actually, you can reduce detention time by doing what? And yeah, you can increase the collector speed, which will shorten the time that the sludge is in that tank. And you can also decrease the number of clarifiers, which push more flow through the other clarifiers, which will then reduce the detention time of those clarifiers. Not the easiest question, but definitely that's how you'd look at breaking that one down. In choosing the chemical to use as a settling aid, you should first you bet, run some jar tests. So last question on this section. A solids washout checklist should include, and maybe you have a checklist like this, maybe you don't, but if you just think about the question, so you've got a solids washout and this question says you got a checklist and things that you should go through. So what would that checklist include? Yeah, I got 1D. Yeah, that's correct. All of the above. You'd want to be checking your equipment, your shear pins, your drives, blanket depths, all that kind of stuff. So everybody did really well. There's a few questions that we had to go through. I think you'll have a good example of some of the things that might pop up on your exam and how to deal with those. Remember to really take a look at the question. I'm repeating myself over and over, but it's important to take a look at the question, look at the data that's provided, and don't make assumptions. I know that myself, writing exams sometimes or doing some things, you make assumptions and that leads you in the wrong direction. Just deal with the information that's in front of you and to come up with an answer. So just give me 2 seconds and I'm going to, I have quite a few more questions that I'd like to go through this morning. I think it's very valuable. So let me get that fired up. We're going to go through a few more questions and we'll take a 5-minute break in a bit, but let's get through a few more this morning. Any questions so far? Okay, just bear with me as I get the new or the next section ready to go. All right. So, you've mentioned a few times, and I'm glad you did because it helped me point me in the right direction that your exams are, everyone that you've seen is in Imperial. I threw this question or kept this question on there only to, I just really wanted to touch on, make sure you have like we talked about this morning, make sure you have a converting calculator handy with you. on an Imperial exam, you may or may not see a question such as this, but a lot shorter time to enter 95 Fahrenheit and then convert it to Celsius on a calculator than it is to stop everything you're doing, try and find the calculation for that conversion. So definitely have a converting calculator with you. And the answer is C, by the way, if you don't have a calculator handy. Okay, what is the function of the bubbler control on a pump wet well? Got one answer, C. Anybody else have a thought? Okay, so the correct answer in this one is A. Being an exam prep course, you know, there's only so much time to go through things. I know that we did not talk about specifically about bubbler control systems. So I'm really glad we go through these questions because it highlights the things that we want to take a quick pause on. A bubbler control is part of a level control system. So typically used on, like in this case, it says like a pump wet well. It's not prone to as much fouling or plugging or issues. And it basically works by, you have an air tube going down, you put air down this tube and the back, and then it bubbles out the tube and goes to the surface. So the back pressure on that airline is what would then converts to a level in that tank. So that's how a bubbler system works. So in this question would be measures liquid flow rate and regulates pump operation. So bubbler control, measuring the level, which then transfers that information and tells you, you know, I want to maintain a level of 2 feet, and so it'll speed the pumps up and down. Okay. To protect a wastewater facility against vandalism, you should not use. Everybody's choosing D. So this question or something very similar is going to pop up on your exam for sure. The correct answer that they're looking for is combination padlocks on gates. And the reason, the thought process behind that is somebody can come along and figure out the combination or cut the padlock off the gate. Excuse me. If you think about vandalism, if somebody's going to throw a rock at something, like a window, if you had a plastic pane, maybe it would just bounce off, where a glass one's going to break. So that's how you take a look at this one. Okay. I know a little bit of a weird question, but something similar will be on your exam, I would, for sure. How can a supervisor be certain that scheduled maintenance is completed? Excuse me. Yeah, you bet. Use a form that compares work signed to work completed. Whether it be a work, whatever the form's called, or a work order, but that's how we get there. So the ash content is the same as the we talked a little bit about incineration and some other things. And if you had heating, drying, incineration, anything that would be left over, the ash would be all of the organic solids. Okay. You're correct that volatile solids would be what's being burned up, but in this question, ash would include all organic solids, anything that can be burned. This question, if you're not sure what, well, let me go through it first. So the most abundant pollutant entering natural bodies of waters, i.e. rivers and lakes, is so 1A. And a couple A's. Okay. Excuse me. So correct answer is D on this one. It's non-point. And non-point pollutants are rainfall, snowmelt, runoff, that type of thing. So make sure you understand what non-point is, or remember what we're talking about this morning, because that one will be on the exam for sure. Something about non-point pollutants. So in this question, it's like, what's the most abundant pollutant entering natural bodies? So domestic food processing in hospitals, hopefully they're going to your treatment facility first, and it says non-point entering rivers and lakes, so that would be directly rainfall, snow melt, any kind of runoff would go directly to a lake or river. Instrumentation friction discs or clutch surfaces should be. Now, when you look at questions like this, even if you're not familiar with what an instrumentation friction disc is, really, or hopefully you have an idea what a clutch is. You know, even if it's a clutch in your car, like if you think about it, so if I have a clutch and I need it to work effectively, what's one of the biggest things? And one of the biggest things is you want to keep that free of oil or anything that's going to. So the correct answer is B, anything that's going to prevent it from causing a tight fit and doing what it's supposed to do. If it didn't have the words clutch in here, you know, if it was an instrumentation friction disc, you'd have to, even if you didn't know what that is, you'd have to think, okay, well, you got to break that question down a little bit. So you have, it's a friction disc. So it's obviously two discs that pushed together at somehow or other, some kind of configuration. And if there was oil or something else on there, then they wouldn't be as effective. If a excuse me, if a generator will not start, check for. You bet, all of the above. Good answer. All right. Here's another one of these fun questions, and we'll answer this one. Then we'll take, let's go through this question, then we'll take a quick 5 minutes so everybody can top up their coffee and whatnot. So given the data below, what is the most likely cause of the problem? So the data here, we have a wet well, increased flow because it's raining. Wet well unchanged and it's at excessively high level. The lead pump's running, the follower, the second pump is running. On your pump, your lead pump check valves alarm's lifting up. The follow pump, the check valve arm is not lifting up. Force main pressure at normal range for one pump. The low pressure switch is normal, or the low level switch is normal, high level switch is normal, and all of your controls are in automatic. So what would be your thoughts on the answer for this one? Again, so what's mostly the problem here is that your wet well is a excessively high level. So what's happening? Yeah, you bet. Good answers. The follow pump is clogged. So the two keys there is the discharge force main pressure is a normal range for one pump. The lead pump's running with the check valve is up, which is a really good indication that there's flow going through that pump. And the backup or the follow pump, the check valve is down, so definitely no flow. Okay, I've got quite a few more questions that I'd really like to continue working on this morning. I hope that's okay with everyone. I think it's a really good discussions. We're hitting some highlights of some things that we need to discuss a little more, make everybody comfortable. A lot of these questions are very similar to what you might see on an exam, so it puts you into that mindset. So we'll take, if it's all right with everybody, I think we'll take that 5-minute break, top up our coffee, and then we'll spend a chunk of time this morning continuing on some of these sample questions. Thank you. So we're going to spend a chunk of the time still this morning going through some questions. One thing I kind of thought of when we were talking about blower aeration type problems, I find it a little easier sometimes with questions if I, on a scratch pad or piece of paper, if I draw them out a little bit. So in that one, it would be, if you drew the blower and then the pipe work and then a drop pipe, and it helps sometimes visualize some of those questions. And again, don't focus on that you may have got a question right or wrong. Focus on make sure you have a clear understanding of what's being asked. Don't make assumptions when you write the questions or when you read the questions. And this is gonna sound a little strange, but they want to draw on your knowledge, which is good, but don't let your knowledge and what you do in your particular facility override what the question is asking or the answers that are provided. So you read the question, you have to understand the question. The answers, the 4 answers are provided. Those are the only answers you have. It's not, well, what if they did this or we do that? That knowledge that you have is tremendous. It's what you do every day is awesome for the public and the environment. But we are writing an exam, and you have to deal with the information that's provided to you. So I'm going to share my screen again, and we'll carry on. Any questions before I get going? Any questions on the stuff we've covered so far this morning? All right. So this one, a chlorine demand test will show the any thoughts on that one? Yeah, C. You bet. Or we had the C. Okay, so correct answer in this one is B. And the thing about, remember, well, chlorine. So basically your chlorine residual equals demand is the amount required, right? Amount required to kill 100% of the coliforms in this answer. Sorry, I messed up their calculation. So it's chlorine dose equals demand plus residual. So your demand is what is required to kill everything. Residual is what's left over. Both of those combined together are your chlorine dose. So commit that one to memory too, because you're probably going to see it. Dose equals demand plus residual. 1 ton chlorine tanks have got one answer and an A. Anybody else? Okay, so if you remember when we talked about chlorine tonners, they have 2 valves. They're typically on rollers, so you can rotate these tonners if you need to. You want to draw liquid chlorine off the bottom and not the gaseous chlorine off the top. At three points on each end of those tonners, there are fusible plugs. So you're correct in the fact that they have fusible plugs, but the plugs are offset from the valves themselves. So this question is, you want to use the bottom valve to draw chlorine gas, which is then it multiplies by or expands by 100 times. So you could use your gas in your chlorinators. Thing about fusible plugs, remember that there's some at either end of the tank. They melt in high temperatures, and that's to prevent the tonner from exploding. And believe it or not, I'm not sure if there'll be any questions on the tonners and fusible plugs about how to stop a leak, but in a tonner repair kit, it may have a cap or clamp to try and stop the leak in a tonner. There are times some of the older exams or older questions will actually have they drive a wooden wedge into that hole to plug up that hole or slow down the leak that's coming from there. Uniform coefficient refers to
Mike, hello.
Yes.
What was the answer to the question before? Sorry.
Oh, D, use a bottom valve. Yeah.
Okay, it can't be B, right? Because when you have to store it, it'll tell you how to store it, or are we automatically supposed to know?
So this question's on 1 ton tanks. So yeah. The tonners, right? Tonners are always in horizontal.
Okay.
Yeah. So the 100-pound or the smaller bottles would be stored. They would be stored in the upright position, right? And there, if you looked inside how the inside of how a 100-pound cylinder was, they have a drop tube that goes down. So you're actually drawing the liquid off the bottom of those tanks inside that tank. But the tonners are always on a horizontal position. So uniform coefficient refers to something on a uniform coefficient question will be on your exam for sure. I've seen it, as best my memory serves, on level 1 or 2 exam. Really, really fancy term, but it just measures, the correct answer here is D, it measures the uniformity of filter media. So just commit that one to memory for sure, okay? You may or may not run across that term in your jobs or your day-to-day, but that's what the uniformity coefficient refers to, is D. So what problems are created when sludge buildup on the bottom of the sediment tank or sediment basin becomes too great? So I've got 1 D. Everybody else agree with that? Yeah, another D. Yeah, you bet. building, again, this is a really good example of just reading the question, dealing with the information that's provided there. And yeah, if you've got a whole bunch of sludge building up on the bottom of the tank, your process efficiency is going to be affected. Localized high flow velocities will be produced. You know, if you've got build up in one tank or one area of the tank, it's going to start higher velocity. It's going to force more flow through the other side of the tank, and sludge scouring would appear as well. So you're correct. The answer is D, all of the above. Jar tests may be used to determine the optimum dosage of. Yep, that's correct, alum. Everybody, anybody not understand what a jar test is? There may be questions on jar tests, so just make sure if you have any questions on jar tests now, or do some reading up on it, but it'll probably be there as well. Okay. Giving the following data, what is the most likely cause of the primary sedimentation tank problem? So flow through the inlet gates is normal. Tank levels where it's supposed to be. Flights are operating normally. Skimmers operating as it should. Collector drives in automatic, so it's running or when it should. And you see gas bubbles evident on the sides of the tank. Some thoughts on that one? Let's see with a question mark. So glad you had the question mark. We can go through it a little bit. So let's go through the question again. So in this one, it's what is the most likely cause? And if you look at the data, so the flow through the tank's normal, the level is normal, the flights are running normal, skimmers are running normal, the drive's in automatic, but we're seeing some gas bubbles, which is denitrification, which is going to be just before rising sludge in that tank. You got to remember with these tanks, everything's underwater, so you can only see so much. So you can't, maybe there's problems with the flights at the bottom that or some of them are broken on the end and sludge is building up. But the key to this question is gas bubbles are evident at the size of the tank, which leads you directly to sludge accumulation. Again, really good example of you can't read things into these questions. You can only deal with the things you provided. Let's step through the answers here. So an effluent, the effluent channel restriction. If there was a restriction in that tank on the effluent side, chances are the level in the tank would not be normal. Right? Flow pattern through the tank. Yeah, that's possibly an answer. So let's just hold on to that one for a minute. C, sludge accumulation. Yep, definitely that's possible as well. And then D, sludge collector drive motor overload. Well, in the data provided, there's no indication of anything wrong with the drive. Doesn't say anything about the drive being stopped. It says the flights which are driven by the drive are operating normally. So that one you can throw it as well. So now you're down to 2, which is B and C. Flow pattern through the tank and sludge accumulation. So if you go back up to the data, flow through the tank is normal, tank levels normal. It doesn't talk about anything to do with flow patterns or flow in general. So I would then take B away, which leaves you with C, which is sludge accumulation. which is going to cause you gas bubbles. It's part of the denitrification. Okay. Okay, I'm going to just skip to this one. So I had a little problem on my end, actually. Let me go to this one here. Sorry, there we go. For the utility records and or rate analysis purposes, customers with similar patterns of water use are usually grouped together into classes. Which one of the following is not generally used? Yeah, you bet. Retail. So we didn't talk about a lot about billing, but if you, really good answer. If you walk through this, which would not be used, we did talk a lot about what's coming into the system. We have commercial, industrial, and domestic flows. We didn't talk anything about retail flows because that would potentially fall into one of those other categories. But yes, you're correct. The answer is B. Especially on the level 2 exam, there'll be similar questions like this, just so you have level 2, 3, and 4, you're getting into different aspects of the job. So they throw in questions like this. The span of supervision is the thoughts on that one? So the correct answer on that one is C. So the span of supervision, so it's basically supervisors are responsible for what, and it's a number of subordinates reporting for each manager. I don't like the wording in this question with, we're all part of a team. So subordinates and stuff, but the question and the wording may be exactly as it's worded. So just remember the span of supervision is what you have to supervise, who's reporting to you. It's not about the supervisors in the organization or the number of levels or length of time somebody's been there, but it's who's number of people reporting to you. This is a good example of something that's going to be on your exam as well. If an organization's departments are organized by jobs to be done, this is known as departmentation or department by. Yeah, you bet. Function. Okay. Okay. Steel tanks may be protected from rusting by. Yeah, protective coatings, you bet. We did talk a lot about cathodic protection for our steel lines and whatnot, and yeah, you could potentially use cathodic protection for tanks, but that's not an answer that's given here. So the only answer that you're kind of left with is protecting that tank. What should be the most important concern of an operator after a bypass? So we had a couple C's. Any other thoughts? Okay, so let's take a look at this question. this question is designed to, one question of B with a maybe. So this question is designed by what your role is as an operator. So if there's a bypass, so we're saying there's bypass, raw sewage went around your plant and directly into the environment. Aquatic life, hugely important, but nothing that you can do about it, typically. Health-related effects, again, hugely important, but as an operator, nothing you can do about it, and odors as well. So the correct answer is B, cleanup procedures. Cleanup procedures would then hopefully help the odor part of it. But you're right in the fact that aquatic life and health-related effects are so hugely important. But the question asks, as an operator, what would be your most important concern? So you have to, what you can do, what you can control, what's part of your job. And in this one is you'd want to be part of the cleanup and get that underway. Okay. And remember, there will be, safety, environmental type questions on your exams too. So, a supervisor could be responsible for an accident in part or completely by yeah, you bet. All of the above. Okay. I'm going to come back to this math question either today or next time. Okay. Which one or ones of the following items should be inspected when responding to a lift station at night? Now, we didn't specifically talk about lift stations as part of treatment, but my group, for example, takes care of several lift stations. Don't let the term lift station throw you off. So whether it be a lift station or something else, what would the, which one of the following items should be inspected? So in this question, it didn't, yeah, B is the right answer, thanks. Motor control center. Okay. A pH of 6 is? Acidic, you bet. Good answers, everyone. Keon, did you have a question on that last one? Just you mentioned, you said weight. Your answer was weight B. I just wondered if you had a question or if I answered that.
No, I was changing my answer to B, right? Because I have lift stations, so I kind of was like, I had to think about it.
Yeah, no doubt. Good point though, and I know I sound repetitive, and I'm just trying to drive the point home. It's you guys. So a lot of these questions you want to sit back and think about. Let's just back up to that one for a minute. It's a good example. If you don't know the answer relatively quickly, then bypass that question and come back to it. If you're faced at the end of the exam and you have one question, 5 questions that you have no idea, that you're not sure, do not leave them blank. A blank is wrong. Take a look at them. Usually you can, out of 4 questions, you can throw 2 of the answers out, which leaves you at least 2. So now you have a 50-50 chance of getting it right. And I'm not suggesting that you don't know what you're doing or you guess at all your answers, but at the end of the exam, you only have 3 hours to write this exam. If you're out of time, you only got a few minutes left, do not leave any questions blank, because if they're blank, they're wrong. Okay. Just bear with me 2 seconds. Just gonna go by a couple of questions here. So biological activity in long, slow flow, flat grade sewer lines will most likely cause yeah, that's right. D, all of the above for sure. Okay. You should never attempt to install, troubleshoot, maintain, replace, or repair electrical equipment panels, controls, wiring, or circuits unless yeah. Good answers, everyone. Employee hazards in collection systems or treatment systems include yeah, D, you bet. GPM means gallons per. Gallons per minute, that's right. There will be some easy questions on your exams and some that aren't, but definitely gallons per minute. GPD would be gallons per day, that type of thing, okay? So let's take a look at this one. A pump delivering at less than expected rate of discharge will not cause this to happen. So what will not cause that pump to deliver a less than expected flow?
Mike, you're gonna have to run me through this question, please. Sorry.
No, I'm not doing it. No. Sure, yeah, no problem. And don't say sorry at all. This is what we're here for, is to make sure we're clear and have some understanding. So, first part of the question: a pump is delivering at less than its expected rate of discharge. So basically, the pump is not pumping what it's supposed to be pumping. We good on that part?
Yeah.
Okay. So what will not cause this to happen? So the pump's not pumping the flow that it should. So what will not cause this to happen? Check valve stuck or clogged. So if the check valve were stuck in the closed position, or maybe there's some rag built up behind it, then yes, that pump could definitely be pumping less than expected. Discharge head too low. Nothing to do with, in this question, that rate of flow through that pump. A discharge head too high, if it was trying to pump to a higher level, could definitely decrease the amount of flow that you're seeing from that pump, because it can't overcome that head. But a discharge head too low would not. So the impeller clogged or fouled, yeah, so something is in that impeller which is not allowing the flow, required flow through that pump. And the pump not primed. So if the pump is a centrifugal pump, if it's not primed, or any kind of pump, if it's not primed, and there's nothing in there for that pump to pump, so it would be producing less flow too. So there's no liquid in the pump, or solids in the pump. So if it's not primed, it's not going to pump. The impeller would be clogged, centrifugal pump, so there's no flow going or not enough flow going through that pump. And the check valve could be stuck or clogged. All three of those could definitely impact the amount of flow coming from the pump, but the discharge head too low would not. Did that help?
Yeah, so the answer is B then?
That's correct.
Okay.
So just remember when you're looking at questions about discharge head, most questions are probably going to be around discharge head being too high. So you're trying to overcome this head and try and pump it out, but a discharge head too low would, so as long as there's some back pressure on the pumps, you're not going to have a problem. Like a discharge head being too low is typically not going to be a problem whatsoever. It's too high, that would be the problem. Wear rings are installed in a pump too. This question will be on your exam for sure. Or something very similar. Okay, so everybody's choosing D. How can I explain this? Yeah, you're right to a certain point, but in this answer, they're looking at concentrate wear on economically replaceable parts. Is the answer for this. Okay. So you're right in the fact that you wear rings instead of other parts, but the correct answer and how their terminology, what they're going to look at on the exam is concentrate wear on economically replaceable parts. Okay. Let's go down to this one. Check valves are used in connection with centrifugal pumps in order to. Okay, so I got a B and I got an A. All right, and I got a C. So the correct answer in this one is C. So let's take a little, let's break this one down a little bit. So check valves are used in connection with centrifugal pumps in order to. So you've check valves on the discharge side of the pump. It's only there to prevent the flow from flowing backwards. It doesn't equalize the pressure. If you look at answer C, prevent water in the discharge line from flowing back. That's the correct answer. B, prevent water in the suction line from flowing back into the reservoir. If you thought about it, it would prevent flow from flowing backwards through the whole pump, through the system for sure. But it's these type of questions is exactly what's happening more on the discharge side of the pump, and because the valve is on the discharge side of the pump, it's to stop any flow from the discharge from flowing backwards. If it did flow backwards, you're correct, it would flow through the pump and then into a tank or reservoir, but it's prevent water on the discharge side from flowing backwards. And just remember that the check valve is always located on the discharge side. Some interesting questions this morning for sure. Enclosed, open, and semi-closed are terms used for the designation and selection of. Okay, thoughts on that one? Yeah, you bet, impellers. So enclosed, enclosed, open, semi-closed are terms of impellers. Bear with me for a second. Okay, let's skip to this one. Vibration in pumps may be caused by improper pump to motor . Yeah, you bet, alignment. Good answer. The most widely used type of prime mover in a pumping plant is? The wording's a little different than some of the stuff we talked about, but you bet, electric motors. Good answer. We talked about a bit about piping before. Not sure if you remember back from when we were talking about piping, but Schedule 340 refers to wall thickness. You bet. Good answer. When packing a centrifugal pump, the packing gland should be tightened. We got some C's and some D's. So let's take a quick look at this one. So just so you know, the correct answer is A. Basically, what they're getting at, and I totally understand where you're coming from. If you replace the packing in the pump, you're gonna tighten it. You know, you've got some leakage, so you're gonna tighten it down. Then you're gonna back it off a quarter turn, which is standard practice to allow enough flow through there. So that's good. But then you have to go back and make some adjustments to that packing, and you probably have to go back a couple times because once you install the packing and then you tighten it down, you back off your by a quarter turn, then you have to slowly adjust that packing so you're just getting a drip. So I understand where you're coming from, but just remember that you have to go back and check this a few times. So the correct answer there would be slowly over several hours. Okay, and just trying to cherry pick some questions. Okay. What type of pump is not seriously damaged if the discharge valve is closed for a short time while the pump is running? Yeah, everybody's choosing A. Good answers. Yeah, so that's I think that's it for the questions or the sample questions this morning. We've only got a few minutes left. I wanted to touch base on a couple other presentations. Before I do that, any questions on some of the questions on what we've covered so far today? A lot of questions this morning are going to be, you know, designed to get you into the mindset of the exams, or especially the ones with the, this is the scenario, this is the data. You're bound to see at least 3 or 4 of those on your exams. I think everyone's doing really well. Just a reminder to don't look too deep, and you can only deal with the information that's there. I appreciate the questions that and the feedback we've had so far, because it was nice things that you weren't clear on that we could definitely talk about a little more. So that was really, really good.
Hi, Mike.
Yes.
I have one suggestion. Sorry for background noise. I came in the office. I was wondering if you could do more of those scenario questions where you have the explaining each part and condition is in, and then we have to find a solution. I think those are really helpful. I was wondering if you could do them for like the other types of plants, also like the RBC and.
Okay. Yeah, I can definitely help you out with that. So when you say the scenario, you're talking about the ones that gave a question and then a list of data, and you had to try and figure out what the problem was.
So like on trickling filters and stuff like that. I think those were really helpful.
Okay. Just making some notes here. Thank you for that feedback.
Also, Mike, I think it's Ignatius. I hope I pronounced your name right. He sent us a sample exam. Can we go through those questions, please? It would be super beneficial.
If I get a copy of the sample exam, sure.
I can send you one. That's fine.
I somehow knew you were going to do that. Yeah, you get that to me as soon as possible, and maybe even the next one. Or Ignatius, if you can send the exam.
Yeah, sure. I'll do that. But Julian, if you have it right up front, you could do that. Feel free to send it to Mike. Yeah.
Yeah, and then Ignatius, either that and send the. I'd like to see the what they have. Do you have the answer sheet as well?
I don't have an answer sheet. I pulled that one up from somewhere. It didn't have the answers, so.
Okay. All right.
Yeah.
Yeah, no problem. I just wanted to make sure. Sometimes they don't align, so I just wanted to check it out. But yeah, that would be that definitely we could take a look at that sample exam too. So come up with some more scenario questions and even a little more focus on those scenario questions for RBCs and trickling filters, and take a look at the sample exam. Any
I wasn't really focusing on RBC and trickling. I just wanted to know if you could do one for like each kind of plant.
Okay.
So like we could get an understanding of each kind of plant is where.
Okay, I will see. I'll see what I can either dig some up or even make some. I can definitely help out with that for sure. Thank you. And the sample exam, was there anything else? You know, how's everybody feeling so far about the information covered? And I know it can be, you know, a little more difficult on Zoom meetings going through these sessions, but I'm just wondering, you know, are you able to assimilate the data and understand what we're talking about? Or do you think you're getting closer to preparing for the exams? I'm just kind of curious.
I'm very curious too, Mike, because obviously this is what we want to do. Hi, everybody. It's Valerie from Operators Without Borders.
One comment that it's very helpful. I'm glad to hear that. Hopefully, we're putting you a little more at ease. There's you know, there's a lot of information to cover. Zoom meetings are, you know, can be effective. Not our preferred method, you know, face-to-face, where you can have some conversations a little better. I do really appreciate everybody providing some chat comments or chiming in on your microphones, and I'm very happy that you're comfortable enough to you know, stop the conversation and ask for some more explanation on things to make them clearer. So that's the only way that especially in this format, that's the only way that I know that we need to expand things a little more and provide a little bit of better understanding. So I'm really glad that everybody's feeling comfortable enough to do that.
And certainly if you're not comfortable, you know, something, everybody just send it directly to Mike. We're here to help you get through the exam. So there's no stupid questions. You know, I get completely lost sometimes. So please ask up. And if there's things you particularly want to cover, just let us know, because as I say, Mike's here to help you. We're all here to help you. And you're the sort of the first group going through this program. So if you do well, it's going to encourage a lot of your colleagues to also sit their exams. And this is what our aim is to get really people qualified and certified in the region.
Great. Thanks, Val.
I think as well, I really like today how you introduced like exam tips. I think that's super useful on how to handle the questions, because sometimes when you're in exams, it's like, what do you do if you don't really know the answer to a question? So, you know, I really liked how you introduced, like, you know, leave it to the end and go back to it. So if you could get more advice on what to do in exams, I think that would be super beneficial to a lot of us.
Okay. Yeah, you know, I appreciate that. Exams are, a lot of people don't write exams every day, or we've been out of school for a long period of time and now you have to sit an exam, and it can be a stressful situation. And nobody wants to do poorly on an exam. I totally understand that. I will give you one piece of advice this morning. If something happens and maybe you don't achieve the results that you'd like to on an exam, that's not a failure. That's not a reason to stop. That's a reason to, okay, let's regroup a little bit. You'll get a breakdown of things that you didn't do well on the exam, and those are things you'd focus on so you could do better next time. These are all chances to learn and make things better for everyone, right? So don't ever take it as a negative. I think too, with the exams, you can only prepare so much. You know, you're attending these sessions all the time, and thank you for that. I know you're doing some reading afterwards, you're being engaging, you're asking questions, you're providing a level of understanding. And hopefully, you know, we go through a few practice exams. The questions, some of them that we pop up might look repetitive, but it's the wording's a little bit different. So when you get to the exam, you know, you've experienced different ways of wording questions, and the ones that are the not or the must or the maybes or might be the, you know, and usually they underline those words in the question. So pay attention to those for sure. Okay.
And I think it's worth repeating, Mike, there's no way that in 12 weeks you can cover every single question that might be on the exam and all of the subjects. It is expected that you bring your day-to-day knowledge into the exam room with you. In Canada, we often hear, well, we didn't cover this and it was on the exam. It's impossible to cover everything in the time. So don't expect us to cover everything. We try to cover enough that's going to get you through the exam and for you to pass. But there will be questions on the exam that Mike will not have a chance to cover in the time that he has with you. So I just want to make that very clear.
Yeah, thanks, Val. I'm just taking a quick second to make sure I downloaded that document. Thanks for sending it. Okay, I just wanted to make sure I had that document. Okay, bear with me. Yeah, and a really good point, Valerie. And I explained at the beginning the PowerPoints, going through those PowerPoints and touching on what I feel are important things that might pop up on the exam. You know, you want to talk about bioreactors or mixed liquor tanks. You could spend a week talking about everything that's involved in a tank, but we're trying to cover as much information as we can, highlighting from our knowledge and experience on things that might appear on the exam, kind of some of the things to focus at. And a lot of it is more concepts. You know, when we were talking about aeration tanks and mixed liquor and solids and organisms, it's more concepts of and an understanding of those concepts. And that same concept can be applied to an RBC or a trickling filter or anything else. It's, you know, biological activity is biological activity, whether it's in a digester or an aeration tank. You may or may not have the same organisms, but it's the concepts around what it takes to support that activity. So that's kind of where we're coming from with a lot of things too. Any other questions? Thank you for sending that document. I appreciate it.
I'll just say goodbye because I have to go onto my call with Nairobi now. See you next time.
Take care. So has everyone gone through that sample exam? Or when did you get that? Like, have you gone through? Have you answered that already?
I've gone through it. That's why I'm asking for it. So.
Okay. Excuse me. Just on a quick look, some really good one to go through for sure. If everybody can take a look at it before the next session, I will make sure I go through it and am ready to go for the next session. We'll start reviewing that one for sure. Take some time, go through it and try and answer it. And then as we go through it, it will really highlight any areas that we need to focus on for people too. So if you can do that in advance, then if a question's not right, we can spend some time and go through it. There's no sense spending a lot of time on questions that everybody's getting right, because you go know the answers for that, you know the background and history. So we need to focus on areas that we need to improve on. And we're running, there's only so many sessions left, and I want to support you as much as I possibly can. So okay, we got time quickly. One PowerPoint I want to talk about today is and there's not very many more PowerPoints left, so you'll see more and more time is going to be spent on questions and sample questions. Allows us time to break things down, but I did want to cover one area today, or one more PowerPoint, so bear with me as I bring that up. If I can find my, there it is. To touch, just like I said, we only got a few minutes left. I just want to talk about phosphorus removal just a little bit. So again, take some time, read through this, but this section talks a little bit about phosphorus removal and different opportunities from whether you're stripping the phosphorus out by lime precipitation or some other chemical means. Keep in mind that I'm not sure about exams, the latest exam, and hopefully you'll be writing one of the later exams, but they may talk about other forms of phosphorus removal. In a biological plant, such as Kelowna or some others, your phosphorus removal is done by wasting. So phosphorus comes into a facility, through whatever method is there, the microorganisms uptake the phosphorus. And then, like this slide says, you can strip it out by lime precipitation or some other chemical process. But if it's a biological plant that doesn't have a process, the way to remove that phosphorus by wasting organisms that are now have taken up some of that phosphorus. Okay. It's important, whether it be phosphorus removal or anything else, it's important to understand coagulation, flocculation, and sedimentation. There may be some questions related to that, those two things. So I'm going to touch on those just briefly this morning. So coagulation is when you add a chemical, whether it be alum or something else, or some kind of polymer to a system. So when you initially add the chemical and you're mixing up, that's your coagulation component. Flocculation is then when you slow things down and allow, you've injected into your flow, so now you're allowing the solids to form larger particles. After flocculation, then those larger particles then get into sedimentations where they're settling out so they can be removed. So just make sure you understand the difference between coagulation, flocculation, and sedimentation. We touched on, we mentioned a little bit about trying to move my head out of the way. Talked a little bit about jar tests today. Just remember, jar tests usually done in a lab. If you wanted to figure out the dosage of an alum, how much alum you'd add, you'd take the same amount of the sample, you'd put it into each one of these jars or tanks in this configuration. You'd inject different quantities of alum into each one and see which one gives your better results. Okay. If there is a question on lime for phosphate removal, try and remember this kind of graphic. You'd have your rapid mix, which is your coagulation part, right? Then it comes into a flock tank. So it's still mixed and moving in here because you don't want things settled out, but it's a really slow mixing system, just a gentle rolling to keep everything in suspension. And when you slow the flow down, it allows the particles then to come together and create larger flocks, and then into your clarifier or whichever, any kind of chamber. And I speak like that because not every lime system has a chemical clarifier, or they may call it something else, but somewhere for the solids to settle out. Okay, and then with phosphorus, with that phosphorus removal, no matter the process that happens to be, once you've created larger flocks and have it settle out, you need to do something with it. You need to thicken it somehow, and then you need to either dewater with a centrifuge or some other type of dewatering process, and then it's off to either land reclamation or something else. Okay. There shouldn't be a lot of questions on phosphorus removal on the level 1 and 2 exam, but definitely remember it's either going to be, if they do ask a question, it's going to be centered probably around something about lime addition for phosphorus removal, or what's lime used for, it's for phosphorus removal. Some other kind of chemical system. If it's a newer exam, it may give you the option, if you needed to control or remove phosphorus, you accomplish that by wasting from your system. Nitrogen removal, accomplished by a couple different applications. So in more advanced treatment facilities, you might do nitrification and denitrification, which allows for your nitrogen removal. Ammonia stripping it may be on the exam. What is, so just to understand that ammonia stripping is part of the nitrogen removal. Breakpoint chlorination, we talked about that previously. Ion exchange, I highly doubt that'll be on the exam, but just if there is something related to nitrogen removal, ion exchange could be as part of the answer there as well. So the conversion of ammonia to nitrate requires significant amounts of oxygen. So keep that in mind. And the conversion actually goes ammonia to nitrate to nitrate. Okay. Requires a lot of DO, lots of energy, lots of horsepower. Okay. And the last thing I just want to touch on, so if you run across any denitrifications, or at least understand the denitrification process by which microorganisms reduce nitrate to nitrogen gas released in the atmosphere. So B&R, or biological nutrient removal facilities such as Kelowna, that's entirely what we're focused on, is nitrification and denitrification. The D-night is definitely harder to do than the nitrification. Nitrification requires a ton of DO, but you can control it all by your amount of dissolved oxygen. The denitrification is the secondary step, which is the hardest one to control. Okay. All right. So stop the share there. I just wanted to touch on those as high points. I don't think there will be a lot of information on nitrification, denitrification, but just understand those two things. And phosphorus removal, there might be some questions, higher level questions related to that. Okay. I think that's about it for this morning. I've got, like I said, tons of questions. I've got about quite a few pages that I plan to go through in the next few sessions. I will, first priority, I'm going to go through that sample exam, get that ready to go for next time. So again, if you could please take, if you haven't done it already, please take a look at that. And then I'll look at some, trying to figure out, either find or create some more of those scenario type questions. And they're good for an understanding for sure. Any other questions from this morning? Anything else that I can focus on in the upcoming sessions to help the process along? Everybody's overloaded this morning. A lot of information. All right. Well, thank you, everyone. Next Thursday, same time, same place, and we'll have some stuff ready to go.
Thank you, Mike, and keep well and safe.
Great, thank you so much.
And all the best to you and yours. And I want to thank the participants who responded at short notice, and it shows that you're really keen on getting your work done. So thanks for your participation. Have a wonderful day, everyone, and keep well and safe. Bye.
All right, take care, everyone. Okay, bye.